represented other senior faculty members team. So it is my great pleasure to introduce our distinguished speaker for today's faculty development program, Dr. AESRIIA, a highly respected academic and research in the field of electrical engineering. Dr. AESRIIA holds a BE from Jadavpur Government Engineering College under North Bengal University and went to complete his ME and PhD from the prestigious Jadavpur University, Kolkata. He brings with him a rich blend of 3 years of industrial experience over 22 years of academic experience. He has served in esteemed institutes like MCKPI, NIT Silchar, and is currently a professor and dean in the Department of Electrical Engineering, NIT Durgapur. Dr. AESRIIA has been actively involved in conducting sponsored workshops, short-term courses and conferences, and has delivered invited talks at various engineering institutes across India. He is also an editorial member of several reputed international journals. Notably, he was awarded an Indo-US Research Fellowship in 2013 and is also recognized as 2% of scientists worldwide by Stanford University. So, this is almost his research focuses on soft computing application in power system, renewable energy, electric vehicles, and he has successfully guided numerous MTech students, also PhD scholars. Dr. AESRIIA is a fellow of IET, senior member of IEEE, and fellow of the Institute of Engineering. Today, he will be speaking on a topic of great relevance and importance of microgrid, smart grid, and renewable energy in India. So please join me in warm welcome Dr. AESRIIA. Please. Today I will say about the microgrid. Before that, actually, I want to know about the participants. First, one by one, introduce yourself. From this college. I don't know from this age. Dr. Ramu from SETGOI. We already. Dr. Thematic from Electronics and Communication Engineering. Please call.
Mohammed Saddam from Mechanical Department.
Myself, Sanjay Prasad from Mechanical Engineering Department, Institute of Knowledge.
So, Prakash Pandey.
from Mechanical Engineering Department at this institute. Civil Engineering Department from this institute. Electrical Engineering Department from this institute.
Amit Chavdar from Electrical Engineering Department of this institute.
Sushobhan Roy, Department of Electrical Engineering, Dream Institute of Technology, Kolkata.
Dr. Sumit Banerjee, Department of Mechanical Engineering of this college.
Dr. Rahul Bhandari from Mechanical Engineering Department, SETGOI.
Dr. Sumit Silchar from Mechanical Engineering Department. Dr. Devojiti Roy, Mechanical Department of this college. Obhi Thakkar, Mechanical Department of Mechanical Engineering, this institute.
Good morning, sir. This is Mohan Banerjee from Department of this college. Good morning, Shoro Kumar Mittal, Mechanical Engineering Department from this institute.
So, Somel Nayak from Civil Engineering Department, this college.
Good morning, sir. Follow from Mechanical Engineering Department.
Good morning, sir. Sir, myself, Paula Bhutte, from Mechanical Engineering Department, this college.
Good morning, sir. My name is Shubham Kumar, Mechanical Engineering Department from this institute.
Dr. Ned Sir, Basic Science and Humanities, Department of Physics, this college. Good morning, sir. I'm from EC Department, this college.
Whatever I understand that most of the participants are from this college and few participants are from the other. Okay, and the department is electrical, mechanical, and civil. Okay, whatever the topic here it is related to mechanical and electrical. I don't know that civil will get interest in this research area. By the way, let me tell so whatever the topic I said in such a way so that all participants can understand. So first topic is that microgrid. Let me know first what is microgrid. From electrical engineer, those who are following know about the electrical grid. What is electrical grid? Those who are from electrical, all of you are faculty. I think that I don't want any kind of definition, but I want concept for the electrical grid. Who knows about the electrical grid? Anyone? Please tell me. I want to make this session interactive session. Otherwise, all of you feel bored and don't get interested. That's why. Electrical grid. So, electrical grid, generally, I want to take the definition. This is a wire connecting point from power meter and distributed, and obviously frequency and voltage will be maintained. Okay. So, suppose power generation, that is less, power demand is low. Then obviously load curtailment is required to maintain the frequency. Okay. Now, the conventional electrical grid, that is generating fast. That's a interconnect. Okay. Now, micro grid, that is small. Micro means small, smaller, isn't it? So here, micro grid is mentioned that it is a self-sufficient system which generates electric power from renewable energy sources and provides electricity to the area. Okay. Let me know that what is power is generated. Okay. Then after that it is transmitted. Then it should be distributed to the consumer or customers, isn't it? But here, in case of microgrid, they are telling that it is self-dependent. So power will be generated, and most of the cases power will be generated from the renewable energy sources. Now, what are the renewable energy sources that will be discuss later on because that's the contribute smartly and renewable energy in India. So in India's renewable energy sources I will discuss. But let me know, anyone know about the renewable energy sources? Any idea?
It is a constant sources of energy which we can inherit energy from that particular constant sources in terms of the ocean thermal energy, geothermal energy, tidal energy, or some other means, small, micro, solar power, solar distribution. So in terms of this kind of energy.
Thank you, Dr. Let me know for your name.
Odisha, Department of Mechanical Engineering, this is
Class 40. Now, according to him, according to him, that renewable energy source that is always limited. Okay, so we can talk about the solar always limited. Wind always limited. Okay, so those are that renewable energy sources. Now, how does actually power is generated and electricity will be distributed to the consumers? Okay, then we can take it as a matter. So, obviously, it does not happen. The electricity generation that's not like gas, but conventional power source. Okay. Now, some other features of the microgrid is the electrical generation and load distribution system. A microgrid can be called as a smart grid or a small grid. Whatever I told, that is mentioned here. This is small scale. And obviously, smart grid, the smart grid obviously I will name in a way what is called smart grid. It is the automated advanced model power system. This customer is now, a microgrid can be operated when it is connected with the main grid as well as it can be operated independently. This kind of connectivity, microgrid can be connected to the conventional electrical grid or it cannot be connected to the conventional grid if you are independently. So, two ways we can do it. One is called one grid and the other called is off. If microgrid is connected to the electrical conventional power grid, then obviously it is known as on grid. And if it is not connected, then we can call it as an off grid. Various clear technologies like wind, solar, gas, or diesel cogeneration fuel cells and microturbines, photovoltaic cells are the main electrical power generation source for a microgrid. So, already you are calling about the renewable energy sources and the renewable energy sources here is generally no conventional energy sources are used in microgrid. Generally, most of the the more distributed energy is interconnected in the microgrid, the more residencies can be achieved. So, sustainability, reliability, if you are talking about, then obviously it's a microgrid will be achieved. However, the unpredictable nature of renewable sources makes the design of microgrid difficult to some extent. Like for solar cell energy can be generated in the nature. So, proper energy storage devices are necessary to generate smooth energy production. Few points that is about the benefits of the microgrid or advantages of the microgrid. Last points we are talking about that. And secondly, unpredictability of microgrid. First, renewable energy sources we are talking about, then it is not smooth like when you see whatever power is there. Okay, another power I am talking about, so smooth power can be always can create the power. So, when we are talking about the renewable energy sources, not only solar, wind, electric, daytime but in the daytime it gets a cloudy weather, then it will get okay. On the other hand, if I am talking about the wind energy, it gets from the wind speed. Okay, so in the storm, high speed you can get it, and very low speed also you can get it. So there is an uncertainty and predictability. We have to go up with this. This is the interpreted or activity. So in our society, what activity is required? The definition of activity in centralized transmission system loss high 88% and to supply load over large geographical areas, the installation cost becomes high. Activity would be a better solution to the cost. Conventional electrical grid, whatever I told, that use power generated from the electricity and it transmitted, the transmission loss will be high. After that, where the load basically is high, there electricity. In case of microgrid, so that transmission loss is very reduced now. Okay, so in that case, what we can see that obviously that loss is less. So in this regard, transmission cost that is also so it is proximate. Electrification in remote locations of the rural transmission is necessary. Extension of electricity cannot be possible in all cases, so microgrid is a feasible option for local load distribution. Rural areas, remote areas, difficult. Some cases there is a technical problem to distribute power from the main electrical conventional electrical grid. Okay, so in those areas, evidently microgrid is the feasible solution. Microgrid provides reliable. So I need to explain certain points here. So in case of conventional energy generation, power generation, if I am talking about the thermal, obviously large landscape is required for the power generation. Huge power is generated. Okay, so that we can avoid in case of microgrid. Not only that, here in case of the microgrid, we are using the renewable energy mainly. So renewable energy sources, obviously all of you know that carbon dioxide emission is reduced or no pollution will get from the renewable energy sources. So obviously this program environmental use. So for this purpose we can prefer microgrid. Those are the actually advantages of the microgrid. Now certain technical things, some cases for the participants, it may be good. I need to clear about the main components of the microgrid. One main component, that is distributed generation. So whatever we generate power from the renewable energy, then we have to distribute it to the consumers generation. So that generation, that is known as the distributed generation. Then loads, consumer customers, their loads. Immediate storage. Why immediate storage is required? That I will tell you. Controller and point of common task. Generally, what your friend knows that obviously the power generated from the renewable energy source is unpredictable. Sometimes we get, sometimes we not get. Okay. So for this purpose, when the power is generated, it very low, it very less. Okay. So when power is being generated for the night or for the other time, we need to use this for this purpose. Storage is required. So when we are talking about the microgrid, we need to think about the storage. Okay. Then controller, that is for the control purpose. Point of common coupling. This is the point where the utility power grid connects to multiple customers and their equipment, marking the interference between the utility and the customer's electrical installation. So, where power is generated to utility and to the customer, power will be delivered. That is the common point. From the common point, it will be distributed to the consumer or customer. There are different types of microgrids. Similarly, I told that it's a smaller range. But what is the smallest range or smaller range? For that, you can take it as a microgrid. So, complex size you can understand. So, large microgrid we are talking about, that is 5 to 20 megawatt. And medium microgrid, that is 1 to 5 megawatt capacity. And smaller microgrid, that is 100 kilowatt to 1 megawatt. This is the size of the microgrid. So generally, I am talking about 20 megawatt maximum power is generated. Started 25 megawatt if I generate from the renewable energy source. Now this is possible. They also get called as a microgrid. On-grid systems are connected to the utility grid, generating electricity and feeding excess energy back into the grid. On-grid systems typically have lower initial costs than off-grid systems. Can rely on the grid during periods of low energy production or when the system is offline. Excess energy can be dedicated or compensated for through net metering reducing electricity bills. Reliance on the utility grid for power during grid outage or when the system is not functioning. On-grid systems cannot generate electricity during a grid outage unless a backup generator or battery system is installed. Less control over energy production and consumption compared to off-grid system. On-grid, what does it mean? We have microgrid, we have renewable energy sources, we have electric power, and we are distributing to the consumer. Okay. Now, this grid is connected to the conventional grid. Then we can call it as an on-grid. Now, there are certain advantages or disadvantages of this on-grid system. Suppose, whatever the renewable energy sources we have generated, that is placed as per the demand. So, we can take power from the conventional grid, electrical grid, and we can distribute power to the consumer. Okay, so these kind of facilities we have. On the other hand, suppose whatever the power we have generated, that is more. Okay, then this more power we can give to the electrical grid. Okay, now when we are giving the electrical grid or when we are taking the electrical grid, there will be our meter. And through this meter, we come to know that how much power we have transmitted, how much power we have taken. Okay, that will be done. Some drawback of this one, suppose there is an outage. During that, there will be a problem in that you have to take precaution of this. You have to disconnect from the conventional grid. Then only you can distribute the power to the consumers. Otherwise, not. Okay, so this is the advantages and disadvantages of the on-grid system. Okay. Off-grid system. Off-grid systems are completely independent of the utility grid, meaning they generate and store their own electricity using renewable energy sources and batteries. Complete freedom from reliance on the utility grid. Provides a consistent power supply even during grid outage or in remote areas with unrenewable grid assets, reduces reliance on fossil fuel, and promotes sustainability energy practices. Off-grid systems including batteries and inverters are more expensive than on-grid systems. Requires conscious energy consumption to manage battery levels and ensure sufficiency. During periods of high energy production, excess energy, there are low power, AC power, power support. Microgrid in India. Microgrids in India were pioneered in the 1990s by West Bengal Renewable Energy Development which is known as Jadavpur. When it installed a 25 kilowatt power solar PV system in Sundarban Delta, microgrid here in Pakistan in 1990s. Then subsequently successful Schneider Electric Agency, which is in AESRIIA, initiated a solar plant in Jadavpur University. In India, solar microgrids made and replicate the first of 1,899 kilowatt power have been installed so far in 63 villages with financial support. 30% of the project cost from the Ministry of Renewable and Renewable Energy. So, NIT, that is Ministry, they were giving support for that microgrid. The government has also introduced a draft national policy for green and microgrids, aiming to deploy at least 10,000 renewable energy-based microgrids. One example. We say just one example, but there are several examples. In Karnataka, the Central Foundation has deployed solar storage remote microgrids to provide energy access in Baikampadi, Mangalore, Nilakantara, village, village and Kerket Sanket Village. The Indian Coast Guard operates a microgrid in Andaman Island. So those are the certain examples of the microgrid in India. Classification of microgrid. Already the size of the microgrid are different, but here depending on the application of the microgrid, it is known as the off-grid microgrid that is designed to provide electricity at remote areas. Campus microgrid are generally interconnected with the local utility whereas it can provide service to some extent when it is also isolated. Community microgrids that are used to provide resilient power in the high priority community zones. Community microgrids are interconnected with utilities. District energy microgrids provide electricity as well as thermal energy. Nanogrids are small scale or smaller scale microgrid units which can act as what about the microgrid advantage already I have mentioned? We have just some points of here. Electrification in remote areas can be done already I have mentioned it. It is self-sufficient system which can be modeled for a large load as well as for a simple domestic user. It can be the best solution to this energy crisis scenario because renewable energy and integration of renewable energy, more and more renewable energy is great because we concern about the pollution, we concern about the environment. So more and more microgrid will be then it depends on the renewable energy sources, means pollution is a eco-friendly energy production is possible. Microgrid has a unique ability that if there is any disturbance in main grid, it can isolate itself from the utility. The chance of a system blackout is avoided. In peak load period, it reduces the load on the grid by supplying some amount of load. The chance of the grid failure is reduced. The heat that is produced at the time of generation can be used for heating purposes. But in conventional power plant, high amount of heat energy is interested. The microgrid is more energy efficient. So here they are telling that suppose there is a peak load demand. Okay. So in that case, microgrid from microgrid it can be supplied. So during the peak load period, if conventional grid wants to to all consumers, then there is a possibility of grid failure. Okay, but in case of the microgrid is connected, it will keep supply and it can overcome this load recovery. Okay, so in this way, it can avoid, help to avoid the grid failure. There are some disadvantages also. The upfront capital costs of designing, installing, and integrating a microgrid can be significant. This includes the cost of equipment like inverters, batteries, and control systems, as well as the cost of power and batteries. Designing a microgrid involves careful consideration of load profiles, generation capacities, energy storage requirements, and control systems. The complexity can require specialized expertise and can lead to longer than an implementation timelines. Interoperability issues. There can be challenges in ensuring compatibility and seamless operation between microgrids and the local utilities, particularly in proprietary control system. Monitoring of frequency and voltage levels is also crucial for effective operation. Protecting a microgrid from faults and disturbances can be challenging, especially in DC microgrids or fault sites can flow into more village. The complexity of the entire microgrid indicators has no rules or energy specifiers. So here are certain points already I have discussed. One thing is that what the microgrid generates is required storage system, because sometimes more energy, more power is generated, obviously we have to store it. Not only that, the operation complexity is more in case of microgrid. When it is connected to the on-grid, then also there is a problem. So you have to use converter and you need to maintain the voltage frequency. That is very, very important part of the microgrid. This is just quick concept or idea about the microgrid I can give you. If you have any question or query regarding the microgrid, you may ask.
Sir, I have a question.
Go ahead.
Sir, we heard about the solar panel installation in the household, right? As part of the thing, the leaf can include the solar panel. So why we are not taking it? Solar panel installing in the household is not something common. So mainly energy supply. Why we are not connecting this solar panel to the grid? Because already in the different countries they are using that system and they are earning money also.
Have you read the disadvantages of the microgrid? What are the disadvantages? That is the problem. So if the solar energy is more, then only you can think about the connection to the main grid. Otherwise, no. When you are talking about the domestic, obviously the energy or the power which is generated, that is only for the purpose of the domestic. Okay. So if you are talking about the community or campus, then you can think about the connection of the main grid. When you are talking about the particular one house or domestic purpose, then it is not at all economically or technically viable to connect the grid. Thank you. Any other question? Otherwise, I have to skip to the another topic, that is smart grid. If you have any question, you can ask. Otherwise, I will skip. do we get some
After 5 minutes, students, 5 minutes.
in India. And they know that all of you know about the electrical grid, main grid, and that I have already discussed. And this smaller scale or small grid is I don't think I have discussed. Now I will discuss about the smart grid. It is a hot and fast topic, not only for electrical engineering, but mechanical engineering is also useful. Here, smart grid, before discussion about the smart grid, from the electrical engineering department, those are from electrical engineering, they tell that in case of the power system, what are the components of the components? One power generation is one component. After that,
Generation, transmission, distribution.
generation, transmission, distribution. Very good. So that also I have discussed in the first session. When I have discussed about that. Now, these three components generally know for the power system is 100% true. But when we are talking about the smart grid, we will include another component, that is customer, that is you. All of you are the customer, all of you are the consumer. Obviously, because when you are staying in your house, you are consuming electricity, you are the consumer, you are the customer. Okay. So, in general case, earlier what happened that what is the consumer's choice, whatever the customer's requirement, that was not considered. But when we are talking about the smart grid, obviously there are some other features of the smart grid, but one important point that all of you should know that we include the customer and the component of the power system. Consumer. Here pieces, here services, everything is okay. Now, here market is mentioned as an electrical meter that can intelligently integrate the actions of all users connected to it, generation, transmission, distribution, and consumers in order to efficiently deliver sustainable, economic, and secure electricity supply. Nowadays, electricity is supplied, but we will think about the certain other components, other factors, that is safety, security, and power quality. So those things we consider for the electricity supply. We take about the smart grid. The smart grid employs innovative products and services together. We can integrate monitoring, control, communication, and self-healing technologies too. Better facilitate the connection and operations of generators of all sectors and technologies, allow consumers to play a part in optimizing the operation of the system, provide consumers with better information and choice of supply, significantly reduce the environmental impact of the whole electricity supply system, deliver enhanced levels of reliability and security. Now, when we are telling about the smart grid, certain features, certain components is mentioned. Here, certain points already considered when we deliver power supply. General case, but one thing we have to consider that more and more renewable energy must be integrated in the grid. Okay, so power generation, if I am talking about, we will depend on the fossil fuels. talking about the thermal power, so more than power generation but nowadays for the environment, for the economy, the power generation, we consider the renewable. When we are talking about the smart grid, obviously must be renewable energy should be included. Okay. Another thing is that reliability and security, because that certain features, certain modern equipment, instrument must be installed. We are working that whatever our relay system is there, suppose we take mechanical unit, that will be replaced by the digital unit. Okay, so digitalization will be encouraged and old and dated equipment instrument will be replaced. Okay, then reliability automatically enhanced. Here, third point just see that third point already I mentioned that provide consumers with better information choices. Here, actually, nowadays most of the cases the communication for the consumer and the service provider is one way, but two-way communication is required. For the two-way communication, instead of the consumers will tell talking receipt provider, service provider will act. Okay. And service provider, if they want to give any information to the consumer for certain purpose, that is taken. Generally, we can do it using the smart meter. I will tell about that one later on. Smart grids deployment must include advanced technology, market and commercial considerations, environmental impact, regulatory framework, standardization uses, ICT information and communication technology, migration, strategy and societal network. In your work, talking about the smart grid, I told that it is advanced technology is used and obviously safety technology is there. Automatically, that is a form of limit. Not only that, it will also prevent the fault in case of the smart grid. One important thing I want to tell regarding the smart grid, a lot of different component instrument will be used. Suppose we are talking about the PMU. Anyone heard about the PMU? Electrical PMU. Result measurement unit. Result measurement unit. This is generally nowadays instead of SCADA, again this is used. Result measurement. Immediately can measure the pressure. Not only that, other electrical quantity it can measure. In a millisecond. Okay, this is advanced one. And for the monitoring purpose, especially this measurement unit is used. This is the advanced of this improvement. Now, generally, this type of equipment always used. Okay, for the smart implementation. Another point I want to say that when we are talking about the new technology, new equipment, standardization is what? So, you know that anyone can travel abroad, so generally, if you go abroad, generally you will face one problem. That is related to the top line. When you want to that is the another problem. Top point. Suppose you have laptop, you want to obviously power supply, you have to use your jack. Okay, so here you have the 3 pins. Okay, for the plug-in. Now you don't have data by go into So for that, travel adapter you have to use, and you have to buy travel adapter from here and you have to go there. Then you can use it. So why I am talking about this one? This is called travel adapter. Travel adapter is used you go there and you get. Okay. So multi points are there. Okay, you can use maybe one and you can use one. Now, why I am talking about this one? This is from the standard. Suppose for all over the world, if the same record is used, then there is no problem. You should not use this one. Similarly, for the equipment or the instrument, the same specification is used here. Then what will happen that the component part of the instrument, part of the equipment, the component that is the buy from anywhere and the replace, and there will be no problem regarding that maintenance or service. So this standardization is important, and that is also maintained. Indian government already has vision to create a strong platform to support for realization of high equity utilization of the power of leadership flow and business. If we implement the smart grid, then a lot of benefit will get. Okay, that point, the implementation and application of the smart grid that we discussed about. Other points that is the smart grid. Here is mentioned. Smart grid is also known as intelligent grid. Green grid is different. Intelligent grid you have that. So whatever the smart grid it doesn't do. Because suppose there is a point will come. Okay. So on that or from the monitoring system, whatever the data you get, voltage or okay. So active control, negative control, from that is to know that there is a fault or not. So you can take precaution of that one. It is smarter one. That's why you can one. That's it. Green grid is different. Do you have any idea about the green grid? Have you heard about the green grid? Anyone? It's not related to the electrical, mechanical or other. Green grid actually, whatever the power for generating, that is from the renewable energy sources, no pollution is. Then you can call it as a green grid. We should have observability tools, data integration and analysis to support advances in system operation and control. It has the ability to handle the unpredictability of loads and effect and market participation, making complex interaction with communication protocols and smart or intelligent devices. It can be considered that smart grid is a supreme intelligent modern power system which can make stochastic demand, handle distributed resources and adapt new environment situation. Smart grid provides more electric capabilities to business values in power delivery control and remote infrastructure. Now, in case of that smart grid, day by day load is increased. So in future, what will be the load demand? Or if the load demand is more, then how to handle that infrastructure should have to get the demand. So you can handle the unpredictable load demand. Okay, so that is one another feature of the smart grid. Not only that, suppose you have the network, whatever it is handling last, you want to enhance your network or system. So in rural area or in remote area or in village, you want to do this. Okay. So you need to expand it. So you want another node, another vast system. So if you want to expand your network, then there will be no problem in case of the span. In general, nowadays we have to again go to analysis, etc. Then we have to increase the population, etc. But smart grid is such that if you want to expand, it can capable to handle this expansion. Okay. Any kind of stochastic design. Stochastic means that data. So load demand that will be variable I'm very clear that computer is the smart. Now, in case of the smart grid perception, there are 3 points. One is transforming the grid, second one is empowering the consumer, and third one is the ensuring the energy. 3 main points. First point is transforming the grid. It is completely technical one. So technical advancement of our power system is required. Here it is mentioned, suppose knowing exactly where a power outage occurs and instantly starting a new fix the problem. Earlier what happened in our village, and one of the product from village, what happened that if there is a fault, after 1 day or after 5 to 6 hours, it will create a nowadays it is not happening. Obviously, for the Durgapur, for the Kolkata crossing is not there, but in village there are some issue is not. But if there is a fault, how is the fault is fixed or solved in short time? How do you know about the RTN, artificial neural network? So here actually fault in case of the fault analysis, there's software and you can also develop this one. What is that? Earlier we are using the AI. We can understand the type of fault, the specification of the fault, and the location of the fault. Earlier what happened that if there is a fault, there is a 400 kilometer transmission line or 200 kilometer transmission line. So if they search for the fault, they understand about the type of fault. After that, they will bring their equipment and they will fix it. Okay. Now it's not there. Now from here, from the control room, we come to know the type of fault and where the exact fault is there. With the proper equipment, you can send your you or the share to fix the problem. Okay. So within few minutes, you can solve the problem nowadays. Okay. So this is all one technical advancement. Another one, extending SETGOI by sensing and managing the space based on aging equipment. Already regarding this I told that aged equipment means that old equipment. Okay, so that if you are talking about this market equipment, that is not to do. Preventing outages before they occur by sensing potential equipment limits. So we need to, when we are talking about the smart grid, then we should have the certain features that we can prevent the fault. We can measuring instrument from the PMU or some other smart monitoring system. We can analyze the data and we can predict that there will be fault or not. And if we understand that there is a fault, so we can take precaution for that and we can prevent the fault. Reducing peak load by communicating with energy consumers and having them turn off on essential machines. It is related to the dynamic tariff. So tariff, I think that all of you know use the tariff. Because when you keep the bill, electric bill, so most of the cases that is the static tariff. Suppose you are using this kind of unit, 7 units, for example 100 units. So per unit cost, for example, is 10 rupees. So 100 into 10, 1,000 rupees. So straight forward simple calculation. But dynamic tariff is different. What I am talking about is morning there will be the rate different, evening the rate will be different, at night the rate will be different. And that will be displayed through your smart meter. Smart meter is there and that will be connected to your mobile. And what will happen that you can get the information that during that time what will be the bill, what will be the rate. According to that, suppose in the evening, generally that is, you can say it's a peak load in the evening. then the current rate that will be low. Then during that time, what will happen that non-essential items will be taken off. What does it mean? Suppose washing machine. During that time, you will not use the washing machine. You will not use the mixer. Okay, so you don't use the mixer or induction heater like this. So you will avoid to use the non-essential item. And you can save money. Okay. So these features will come in future because of the smart implementation. And empowering the consumer, here it is mentioned already. So billing system will be cost and on time that billing will be there. And obviously in the smart meter, customer will get the information from the service provider, and if there is a need for the customer, that can be transferred. So in this case I am telling you that in case of European country, Western country or America, generally always customer run for the power quality. What is power quality?
Power quality is nothing but the voltage.
Okay, voltage. Another factor is here. Power factor.
What is that? What is
Voltage,
that?
regulation, voltage,
Imbalance.
imbalance.
What is trigger?
Okay. So those are the generally for the sophisticated instrument, if there is a change in voltage structure, so there is a constant structure. Then and that the longevity of the instrument value is down. So longevity that is a problem. And not only that, not measuring instrument, sophisticated measuring instrument, it will be the wrong result with the voltage frequency that is given. That is practically. So because voltage load factor, suppose velocity is given, load factor is so that is called the service, continuity of the service, that is also given. Suppose again and again you are facing the grocery or load factor, you are getting the electricity supply. You can run that. Okay. So that is one part. And harmonies and that is the particular category. That is also another. Okay. Generally we come if it is not from the industry, not from the air flow, which is more like this. So generally we prefer generally to replace the frequency of this. Okay. And another one, continuity of service. So another thing is mentioned that generally rules that certain equipment components is not a way so that you can save the energy and you can save the fuel. Okay. Suppose instead of that all that in okay, that is one. Or I start